All right, so 4A actually is solving by factoring and something called the even root property in it. So basically, we are going to take what we've learned to factor and take it one step further because those are going to be in equation form. So when we said factor completely, there was never an equals in those statements, right? So now there's going to be an equals somewhere in there. And these are what you're going to work to do. You're going to get all the terms on one side, setting it equal to 0. For the most part, you'll put them in decreasing degree order. You'll factor it using all the ways we know how to factor. And then you'll split up each term or each set of parentheses and you will solve each one. So you get multiple answers here. So let's look at these, right? We start a little bit easier on the factoring side. How would I factor number 1? Good, it's the difference 2 squares, right? So x plus 1, x minus 1. And then we get it in the factored form, and if either of these parentheses are 0, it makes the whole thing 0, right? Like if I had a 0 as this parentheses, my whole statement becomes 0. If this one's 0, the whole statement becomes 0, which is why we can then split this into 2 parts, setting each equal to 0, and then solve them. So from the left side, I would want to solve x plus 1 equals 0 by subtracting 1, and I get x equals negative 1. And on the right side, I would add 1. So I get x equals negative 1 and positive 1. There are 2 answers to that. They are usually written in decreasing order, in increasing order, so the smallest comes first, but it's not like it's wrong if they're not in that order. Okay, now look at 2. First of all, both of them were already set equal to 0. If they weren't, I would move everything, but these are already set equal to 0. So how do I factor this one? Good. Take out the x, and I get x times 3x plus 1. And then I split and solve. So this is 0, and this is 0. That means x equals 0 is one of my answers. And then 3x would equal negative 1, and x would equal negative 1/3. So in order, my x's would be negative 1/3 and 0. Doing good? Yeah? Okay. 3. Here's what you cannot do, and this is what people do. They take both sides and divide them by x. This would be 1. They would cancel one of these and I get x equals 1. It's wrong. You cannot cancel them out when you are solving to factor. Solving, okay? You have to do what we're supposed to do, which is get everything to one side. So I'm going to subtract the x. And I get x squared minus x equals 0. How do I factor that? Take out an x and I get x times x minus 1 and split and solve. So x equals 0 is one answer, and x equals 1 is the other. If you think about what would have happened had I canceled through the x, we just lost the x equals 0, which is a solution. So that's why you can't do it the first way. Okay, now comes 4. So it's already set equal to 0. What kind of factoring am I going to do? You can do first and last, okay? There's nothing in front of here. It's just a 1, so you could also just do what? Not grouping. Factors of negative 8 that sum to positive 2. So x goes here and here. What are the factors of negative 8 that sum to positive 2? Positive 4, negative 2, and then we split and solve. So x would equal negative 4 and x would equal positive 2. All right, 5 is now what? First and last, or trial and error, but there's a term at the front now, right? So 2 times negative 15 is negative 30. What are the factors of negative 30 that sum to negative 1? Negative 6, positive 5, good. Replace the middle term with those. And then factor by grouping. So first set of parentheses, you can take out what? Good. Second set, positive 5. Take out the x minus 3's and group together the 2x plus 5. Split them and set them each equal to 0. X equals 3 on the left. 2x equals negative 5. And x equals negative 5 halves from the right. All right, you do the rest on this slide. I'll give you a hint. You're going to have to move something every time, right? Because it's not equal to 0. All right, so what's the first step for 6? Subtract the 3. 2x squared plus 9x plus 4 equals 0. Now, if you do first and last, 2 times 4 is 8. Factors of 8 that sum to 9. 1 and 8. Replace those. It doesn't have to be in that order, but it can be. Factor by grouping. Take out the x. Take out a 4. Sorry. Take out the 2x plus 1, and then group together the x plus 4, and you get negative 1/2 and negative 4. Questions on that one? Okay. 7, first step is what? Subtract the 3x. Then?
Take out the 3x.
Good. Take out a 3x, 2x minus 1. Split and solve. Divide by 3. 0 divided by 3 is 0. And then 2x would equal 1, and x would equal 1/2. Good on that one. Okay. 8, pretty similar. Subtract the 2x again. Take out a 2x. And split and solve. I get 0 and 1/4. Raise your hand if you got all 3 right. Good. Okay. Any questions? All right, let's do number 9, and then we'll actually do 9 and 10, and then we'll come back to 11. All right, so 9, once you move the 6x and the 9, you have to move both this time. I wouldn't move the x squared to the other side. You get a negative in front of the x squared. So I would avoid it if you could. Wherever the x squared is, you want to move the other terms to it. Okay? So then 3 and 3 are the terms that would multiply together to give you 9 and add up together to give you 6. You don't need to list negative 3 twice. It's one answer, so you only need to list it once. Okay? When you get to 10, you can do first and last here. Okay? But what else could you check for? Perfect squared trinomial. If the first and the last terms are perfect squared, check that first. It's going to be easier. So remember the check there is that this would be square root of 4x squared would be 2x. Square root of 9 would be 3. Double the product. So together this is 6x. Multiply it times 2 and I get 12x. If that equals my middle term, then it is a perfect squared trinomial. So to factor it, we square root the first. We square root the last. We take the sign from the middle. Now, if there are 2 of these, it just means this. It would be repeated, right? I only need to solve it once. So you just solve the 2x plus 3. And I get x equals negative 3/2. You only need to solve it once because it's the same. If you had done first and last, you should get the same answer, okay? just think the perfect square trinomial is easier. You just got to catch it. And sometimes those perfect squares get big numbers to do first and last. Okay, we'll come back to 11 tomorrow. Let's review. 12. This time the x is negative. What would you do? You could, I heard two things. Divide by -1 totally works. I could divide everything by -1 as long as I change the sign on both sides. What else? Move the left side to the right side. There's no rule that says the right side has to be the 0. Okay, so you could do either way. Just remember you're moving both of these. So it'd be 0 equals x squared minus 4x plus 3. And then factors of positive 3 that sum to -4 would be -3 and -1. Split and solve. And I get 1 and 3. Here's the great thing about these when the answers are kind of on the simpler side is these are easy to check. Plug that number back in and make sure the left side of your equation equals your right side. Okay, obviously when you start dealing with fractions, it gets a little bit harder to check. But your whole numbers should be easy to do with the extra time. Plug those back in. Left side should equal right side. Okay, how about 13? What would you do first? Good. Get rid of that fraction. Multiply everything by 8. So I'd get x squared minus 8x minus 128 equals 0. Now I'm working through the factors of 128 that are 8 apart. So I could start with 1 and 28, but that's pretty far apart. I could go to 2 and 64, still pretty far apart. 3 doesn't go into it. 4 and 32, still far apart. 5 doesn't go into it. 6 doesn't go into it. 7 doesn't go into it. Does it? No, 7 doesn't go into it. 8 would be 1. Thank you. And those are the ones that are 8 apart. Negative is bigger, right? Because the negative's here. So this would be 8 and -16, which is what we did to be in the beginning to get to it. Okay? X plus 8 and x minus 16. Yeah. Not really. No. You're not going to get a bunch of those, though. Yeah. You're going to learn other ways to solve it, but if it was factoring, unfortunately, no. Yeah. You could start closer together if you wanted to, because you know they're only 8 apart. Like you could have gone in reverse. Yeah. All right, subtract the 8. X equals -8, and then add the 16. And if I had just remembered that I had multiplied those together to get that last, it would have been easier too. Yeah. So -8, positive 16 are my answers. Questions on those? Yeah.
So when you're like checking like your work, would you just plug like each of them in?
Yep. Yeah. You can plug them back in at the beginning. If you've moved things left to right, you can plug them back in there. It doesn't matter. Beginning safest just because you know that that's right. Yeah. All right, so that was solving by factoring. We are going to learn how to solve, these are all quadratics, raised to the second power. We're going to learn how to solve quadratics a bunch of different ways. That is the first way, which is solve by factoring. When you get your quiz or test, it may say solve by factoring, or it may say solve and you get to choose. So you're just going to pay attention to the directions. The second way is solve by square rooting, okay? This is something that uses what we call the even root property. That's what you're, like when you get to pre-cal, that like I always refer to as even root property, okay? But you're basically going to be solving these by doing square root. To do these, you can only have an x squared. You can't have an x squared and an x. So if you have an x squared and an x, you're factoring, okay? Or a quadratic formula, which we'll get to later. If you only have the x squared, then you can do this, which is get the squared term to one side. So just the x squared, a squared, b squared, m squared, whatever variable it is, on the side by itself. And then you're going to square root both sides because that's the opposite of squaring. But you have to remember something called the even root property, which says that if I had x squared, it's really hard to see, x squared equals 25. When I square root this, think about what answers can go into x. Not only can a positive 5 go there, but a negative 5 can also go there. So when I square root both sides of the equation to get rid of a squared on a variable, I do a plus and minus at the front of the square root. So this answer is really plus and minus 5. There's two answers there, positive 5 and negative 5. So that property is called the even root property, okay? But you have to remember to do it. If you don't and you only square root that and get 5, you only have half your answers. It has to be plus or minus. So the rule is when it starts with a variable squared and we bring in the square root, we go to square root it, you have to put the plus and the minus in it, okay? Don't confuse that with the square root of 25. What is the square root of 25? It's just 5, okay? But if I had x squared equals 25 and then I bring in the square root, then it's plus and minus because you're solving for a variable and there can be two values there. All right, so let's look at 14. X squared, first of all, there's only one x squared, right? There's only one x. It's already on the side by itself, so I just have to square root both sides of this equation. And in doing so, I'm going to put a plus and minus in front of the square root. The square and the square root cancel out, and I get x equals plus and minus the square root of 15. Can I simplify the square root of 15? Nope, it stays just like that. Go to 15. Square root gets a plus and minus, and I get x equals plus and minus the square root of 48. Can I simplify that? Yep, here comes our factor tree. 2 and 24, 2 and 12, 2 and 6, 2 and 3. There's one pair of 2's, so one's going to go to the outside. Second pair of 2's, another 2 goes to the outside. 3 stays under by itself. So x equals plus and minus 4 square root 3. That means my answer is negative 4 square root 3 and positive 4 square root 3. So if this is just a short answer question like on a quiz or a test, I'm fine with plus or minus 4 root 3, but obviously when you type that into WebAssign, you're going to keep them separate. And WebAssign will usually tell you put it in order of least to greatest, and then that way you know it's in the right order. Questions on that one? Okay, so now look at 16. The whole thing on the left is in the parentheses squared, so I can't break it apart, okay? I have to get rid of the square root. So I square root both sides of this equation, putting a plus and minus in front of the right. And I get 4x plus 1 equals plus and minus the square root of 20. Can square root 20 be reduced? Yep. How do I rewrite that? Good. It'd be 2 and 10, 2 and 5. 2's come to the outside. And I get plus and minus 2 root 5. Now I still got to work to get the x by itself, so what do I do next? Subtract the 1. Now the easiest way to write this is negative 1 plus and minus 2 root 5. You can also write it as plus and minus 2 root 5 minus 1. That's okay too. And then my last step, divide by 4. And I'm going to write it all as one fraction. Here is what you cannot do. Don't do that. You cannot simplify only half of your fraction, okay? Only if they were all divisible by 2 would I reduce it by 2, okay? Or you can split this and then simplify it. I could rewrite that as negative 1/4 plus and minus 2 root 5 over 4 and then reduce this, but you don't need to do that, okay? You can keep it just like this. Again, on WebAssign, it will separate it out, so it would be negative 1 plus 2 root 5 over 4 and negative 1 minus 2 root 5 over 4. And the order there doesn't matter. You can switch those. It could have been positive 2 root 5 minus 1. You can switch the order, okay? It will still mark it right. All right, 17 we're going to come back to tomorrow because it's a lot like the other one. Okay, now we've got a term in front of the x squareds, right? So if you look at 18, that x squared is not by itself. The whole parentheses is not squared. There's something attached to it. Before I can square root this, I got to get rid of that 9. How do I get rid of it? Good. Divide both sides by 9. And I get x squared equals, and 9 goes evenly into 36. If it didn't, I would leave it in fraction form. Now, square root both sides, put that plus and minus in the front. X equals plus and minus 2. Now look at 19. 37 is not a typo, it's a yucky number on purpose. What do? Divide by 25. And I get x squared equals 37 over 25. Doesn't divide evenly. I'm sure as heck not going to put that in mixed number form. Okay, don't do that. Now what? Square root both sides, putting that plus or minus in the front. Now a square root over a fraction means there's a square root of the numerator over a square root of the denominator. Can I go further with that? Yeah. What do I get? Good. Square root 37 over 5, negative square root 37 over 5, and positive square root 37 over 5. Yep. On WebAssign, I think it's going to have you separate them. On your quiz, you could have written plus or minus. All right, 20. Step 1 is what? Square root both sides, putting a plus and minus in front of that 25. X minus 5 equals plus and minus square root 25, which is 5. So I get plus and minus 5. And then add this 5. And I get x equals 5 plus and minus 5. This I can actually simplify. This is two different answers. I have one that is 5 minus 5, and I have one that is 5 plus 5. So 0 and 10. We're going to come first step. Square root both sides, putting the plus and minus in front. So 4x plus 7 equals plus and minus the square root of 44, which is 2 and 22, 2 and 11, or 2 square root 11. Then I subtract the 7. So 4x equals negative 7 plus and minus 2 root 11. And the last step, divide by 4. So that whole thing is my answer. Negative 7 plus and minus 2 root 11 over 4. Again, in WebAssign, you're going to separate it out. So negative 7 minus 2 root 11 over 4. And negative 7 plus 2 root 11 over 4. Cannot simplify the 2 and the 4 because of the 7. Now, before we get to 23, I want to show you one quick thing. Actually, wait, no. Okay, so what would you do on a question like this? I think there's one in the homework. What would be step 1? Divide by 5. X squared equals 7 over 5. Then what? Square root both sides. Put that plus and minus, and I get x equals, this would be plus and minus square root 7 over square root 5. Can it stay like that? What do you got to do? Ew, it's back. Yes, you have to rationalize, right? Square root 5, and I'd get plus and minus square root 35 over 5, which does not go into that. You have to leave it as it is. Questions on that one? So if the bottom is not a perfect square, like the last one that we did, right? It was perfect square. It's simplified. Then you have to make sure you rationalize it. You cannot leave square roots in the denominator. Okay, let's come back up to this one. So what's different with this one? There's a square root on both sides, okay? So it doesn't matter which one you put the positive or negative on, but you do have to put a positive and negative in front of one of these. So if I go to square root both sides of these, okay, and I say this one gets the plus and minus, that's fine. Or the other one gets the plus and minus, doesn't matter which one. But you still have to put a plus and minus. So the square root and the squared are going to cancel from the left, and I just get x plus 5. And the square root and the squared are going to cancel from the right, but the negative and the positive are there, which means there are two questions or two answers happening here. I can literally split this into two different equations. X plus 5 equals a positive x plus 4, and x plus 5 equals negative out front, which is going to get distributed to both the x and the 4. So on the left-hand side, if I subtract the x, they cancel, and I get 5 equals 4. That doesn't work. X plus 5 would equal negative x minus 4. Add the x. 2x plus 5 equals negative 4. Subtract the 5. Divide by 2. And again, just because one cancels out doesn't mean the whole thing is no solution. You keep the other one. So that negative 9/2 would have been your answer. Sophia.
Just to keep it like that or put it in a mixed number?
Better to keep it improper. Yeah, you don't need to do the extra work. It's going to be easier to keep it improper if you're going to check it. Any questions on any of the ones that we worked through today? So we did two different things today, solving by factoring and solving using square roots, okay? Those are two of the many methods you're going to use to solve quadratics. Any questions from last? Okay, so I'll do it that way just so that you can find your mistake, but I would have totally cross multiplied. It's so much easier, okay? So did you take out a 3 or did you just do 6 times 3x plus 9? Okay, so 6 times 3x plus 9 and 6 times 3x plus 9. So on the left-hand side, the 3x plus 9s cancel, and I get 6 times 3x minus 3. And on the right-hand side, the 6 cancels 5 times 3x plus 9. Distribute 18x minus 18 equals 15x plus 45. Subtract the 15x. Add the 45, or add the 18. And then divide by 3. So it's 21. Mm-hmm.